Okay, so we have this question is a proof now. We are going to see how do we apply that. A particle is projected vertically upwards with the velocity that. And after t, capital T, this is capital T, another particle is projected vertically upwards from the same point with the same initial velocity. Prove that they will meet at a height of that. So what do we handle there? So I have the first particle. This is my first particle. The first particle. And it's going to be my first particle. So it's projected from here upwards. So now, after that, telling us that the initial velocity it's using is u equal to 2 per second. Now, we also have a second particle here. The second particle. Now this one, they are telling us that the same, with the same initial velocity, so also this initial velocity here is going to be u meters per second. Now, the acceleration, because they are going upwards, the acceleration here is going to be negative v, and also the acceleration here is going to be negative v, because all of them are opposing gravity. So after that, they now need the time. So if the time for this, so they are telling us after t seconds, after 2 seconds. So I'm going to call this the time for this now, because starting at t seconds. So this is what is going to be the time. Now, what about the time for this that went first? So meaning this one is going to be the time for this one, then plus a certain time t, which because this one is earlier, went earlier. So if this one is time t, then this one is going to be t plus 1, because it's faster, it went earlier, that's why we add a second time t, we don't know. So from there now, they're telling us that at a certain height, it means that the distance they would have covered for them to be equal, for the distance to be equal, so that the time, the height, they will meet at the height is, so at that height, their distances will be the same. So first, they are going to get a distance of this particle, then they get a distance of the second particle. So the distance for the first particle, S1, is going to be, let us call it's going to be u. You know that it's always given by u, the time. So the time is going to be t plus t, then minus half g t plus t the whole square. Now this is going to be our distance. Can we expand? So our S1 is going to be ut plus u small t, then minus half g t squared plus 2t, expanding this t squared. So from there, we can every expand that. So we are in ut minus half g t squared. This minus is going to affect this half, it will fall off. Get dt, then minus half g t squared. So this is our S1 for the first particle. Then for the second particle, so let us call the distance S2. We are going to be having now ut, then minus half g t squared. Because resistance time is t. That's why we are using the equation. We are using the equation S equal to ut plus half a t squared, where this time is time. So the time here is t, our acceleration here is negative v, then the t is there. That's what we are having there. So here our time is all of this, then this is negative, then there. Now, at the point, at the meeting point, or at the meeting height, then it implies that S1, our S1, should be equal to S2, meeting height, for them to be all at the same height. So S1 should be equal to S2. So putting it here, ut be equal to S2, which is ut minus dt squared. Now, we start in our proof, we don't have this capital T in. So our task is to eliminate the capital T. So first of all, when you look at this, you see that, first of all, this will vanish with this. Then also this will vanish with this. So here, I'm going with ut minus dt t minus a half dt squared equal to 0. Now my task is to make this the solve, so I take it the other side. So my ut minus minus a half dt squared will be equal to dt. Now, so I divide through by dt and also divide by dt. So from there, my t will be, so it's like this, we will cancel with that one there. So my t will be now, this divides here, I'll be having u. Okay, I'll be having u. Ut, okay, I'll be having u over d when this divides this, then minus when this divides this, I have a half, then this will cancel, then this minus on my t, this will cancel, then that will also cancel. That's my t. Now this is equation 3. Now I said from, now if I have t, I come and I substitute. From in the easiest equation, so this one is easier to substitute than this, the capital T, because we don't want this capital T in. So from S2 equaling to ut dt squared, let us substitute. We have u into now u over d minus t over 2. Then minus a half d into u over d minus t over 2, the whole square. So there, what are you going to do? We are going to get the LCM and we expand that. So here, cross multiply u2 2u minus dt, the whole over 2d. Then minus a half d into, let us expand this, u squared over 2 squared minus this and this, then by 2 shall be adding ut over d, because this half, remember when I multiply this by 2, so this half will fall off, that's why we have that. Then plus d squared over 4, expanding. So can you open brackets? When you open brackets here, I have 2 u squared minus u dt, the whole of this over 2d, then minus, multiply here, this will cancel, I'll be having now u squared over this 2d, then minus, when I multiply here, this will cancel, so I'll be having ut over 2, because this will cancel this, so this negative and this negative will give us positive. Then this now this 50 will survive. Then this negative and this negative shall make a negative. Then d this square, the whole over 8 times that. So from there, let us get the LCM. So the LCM is going to be, let us get the LCM. The LCM, you see, this is contained, so this one is contained in, so the LCM is going to be, this is contained in, so it's going to be 8d. So the LCM is going to be 8d. So now, this goes in here 4 times. So 4 times this will have 8u squared minus 4dt minus, this goes here 4, so 4u squared, then plus 2 goes here 4b. 4b times this will get 4b U. Sorry. Yeah, I'm forgetting U. U. For GU, T. Then minus this 8 here goes here. G times this. G squared. D squared. And from there, you see that this one will cancel with this. So 8U. Just that this will be now 8U squared minus this will get 4U squared minus G squared D squared all over 8D. And that's what will be the limit at the height. So that will be the height, same height. The height for them to meet, that will be that proof there. So I think that's it. Members, you have to be careful with the algebra there. See you there.